Now before I get into transformations, I just want to quickly go through how to graph the reciprocal graph. This isn't typically on a test or an exam, but I feel like it's something that you should be able to do. All right? If you're asked to graph one of the reciprocal functions, what you should do is first of all graph what it's the reciprocal of. So secant is 1 over cos. So I'm going to quickly draw cosine here. Okay, and you should be able to do this pretty quickly if you've prepared well enough. Okay, so this is pi by 2, pi, 3 pi by 2, 2 pi. Okay, and again, I'm just going to graph from 0 to 2 pi. The cosine graph looks like this. Okay, something like that. All right, so what we are going to do now is the reciprocal. All right, remember, you're thinking, well, secant of x is 1 over cos. So we're going to do the reciprocal of cosine. And if you remember our steps for graphing reciprocal, first step, and remember there were 4. First step is where does it have its x-intercepts? Because the reciprocal of the x-intercept is a vertical asymptote. Okay. Next, you're going to say, well, where is the graph equal to 1? Here, and here, and where is it equal to -1? Right here. Then, you ask yourself, where is this graph getting bigger than 1? Well, you can see there is nothing up here greater than 1, so that doesn't affect us. But this graph here, as it approaches the asymptote, it's getting much smaller. And what's the reciprocal of something as it gets smaller? The reciprocal is it's going to get bigger. All right, same here. Where the original graph is getting smaller, the reciprocal will be getting bigger, and it's going to have asymptotic behavior at the asymptotes. Okay, and actually this graph is going to have a whole bunch of, just going to keep repeating like that. Okay, so that's your secant graph. We should probably say it continues like that, continues like that, because there will be asymptotes, and it will, just because the cosine graph also, right, it's going to keep doing this, and so same with the secant graph. Okay, let's try another graph. So when I see this, my first thought is I should graph tan x. Good practice. And if you remember, it had asymptotes at pi by 2, at 3 pi by 2, etc. And then there were values, we had x-intercepts here. Okay, and so the tan graph looks something like this. So what we're going to do is we're thinking, well, what is cotan? It's 1 over tan. So we're going to do those 4 steps. First of all, where is this graph equal to 0? Right here. Right here. And right here. All right, where is this graph equal to 1? Right here, 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 -1, here, here, here. And interestingly, where the original tan graph had an asymptote, why was there an asymptote? Because sine over cos is 1 over 0. If we do the reciprocal, you're going to have 0 over 1. So where the asymptote was, there's going to be a 0. All right, and so this graph is going to look very much like the tan graph, but just the opposite curve or opposite wave. All right, and that's your cotan graph. So spend a couple, try and do those a couple times, and then we will continue with the trig functions next lesson.